Where you at? Where are you at on it? And I don't have mine with me. Can I borrow somebody so I can write the problems up real quick?
On like 7.
I ended on 7? Okay. So I finished 7 or I...
You're in the middle of 7.
Middle of 7. So does someone have one I can borrow? Can I borrow yours? The middle of 7. So we were talking about the end behavior. Did I actually go through the...
E-wall.
Okay. All right, let's go through number 7. So number 7 asks about the end behavior asymptote, which is also called the oblique asymptote, right? So this is not a synthetic division. It is a long division to which you don't necessarily worry about the remainder. So I have x plus 2. I'm going to divide into this. Now it's going to be your choice. Do you want to put the x squared as a placeholder or not? It's up to you if you want to. I'm happy to put it. So let's go from there. So I'm dividing by 2 terms, so I'm going to start 2 places over. Okay? What do I have to multiply times this x in order to get 2x to the third? 2x or 2x squared? Squared. So 2x squared times x is 2x to the third, and then 2x times 2 is going to be plus 4x squared. I'm going to subtract. We okay? This is gone. Minus 4x squared plus 4x. You okay with that? Now what should I multiply this x by in order to make it negative 4x squared? Minus 4x. Negative 4x times that, negative 4x squared. Minus 8x. Again, we're subtracting, so those cancel. Negative, negative becomes positive, so that becomes plus 12x. Bring down the negative 1. What should I multiply x by in order to get 12x? 12. So plus 12. So subtract here. That's 0. Oops. That's 24, right? Minus 25. All right. That's my end behavior asymptote. So if I were to graph this, the end behavior asymptote is going to be doing this. Okay? What's the remainder of this? That's the remainder right there, negative 25. Okay? So my end behavior asymptote is this. If I ask for just the remainder, though, maybe you have a problem that says, hey, what's the remainder of this? It means do the division. Whatever this last line comes out to is the remainder. Okay? So then the next one, we had g at x, same thing, said, hey, we want to know the end behavior asymptote. Now, what is sticking out on these problems to say we have an end behavior? What is the thing happening with these problems that says there's an end behavior asymptote taking place?
The degree on the top is bigger.
The degree on top is bigger. That's exactly right. Okay? So then I got x squared plus 3x minus 1 into 3x to the 4th plus x to the 3rd minus 2x squared plus x minus 2. Okay? I have 3 terms, so how far over should I start dividing? 3. So I'm going to start dividing over here. So what should I multiply times x squared to give me 3x to the 4th? 3x squared. 3x squared times that is 3x to the 4th. 3x squared times that is plus 9x to the 3rd. 3x squared times negative 1 is negative 3x squared. Again, we're going to be subtracting these, so that subtracts, it's gone. This becomes x to the 3rd minus 9x, so that's negative 9x to the 3rd. This becomes a positive, right? So that's going to give me plus x squared. Bring down the x. Yeah, that's supposed to be an exponent up there. Sorry about All right, what should I multiply x squared by to get negative 8x to the third? Negative 8x. Negative 8x, I get negative 8x to the third minus 24x squared plus 8x. Oops, I read that on the wrong term. That should be an x, right? I don't know why I got an 8 there. Oh wait, was that what you had said? That was supposed to be plus 8x? Am I right now? Okay. Alright, so this cancels those out. That becomes 25x squared. So if I add those 26x squared plus 9x, bring down the negative 2. And then what should I multiply x squared by to get 26x squared? It's just 26. This is my end behavior asymptote. I don't even have to work out to find the remainder of that problem. Okay? There was another problem, I believe number 8. When using synthetic division, what determines the value as a 0? So if I had some problem that I had written, so this is number, 8? If I use synthetic division, and I have, 3, 2, 6, 8, 7, 1, and I go through and do all the math, what has to happen right there to tell us that this is a 0, or that is where it crosses the x-axis? What has to be a 0 right here. That's all I'm looking for. I have a 0 for a remainder. We're talking about it was a factor of it. It's a 0. It's going to cross the x-axis, and that's what we're dealing with. Does that make sense? Number 9 says this. We have this. And we want to know what this and what this are. Which one's a 0? And then use your graphing calculator to find all of the rest of the zeros. Okay? So, item 1. Some students might look at this saying, hey, I'm going to go through and start factoring it. Why is this not going to factor by grouping? What's different up here? There's 5 terms. Excellent. Okay, so there's not 4 terms. So don't get stuck in the factor by grouping mold if there's 5 terms or 3 terms. So then, let's figure out what this is going to be. So I can do this one of 2 ways. I think someone brought up the other day, hey, can I just plug 3 into everything and see what I get out? Yes. Can I use synthetic division and see what I get out? Yes. Both are the same thing. So I can plug 3 and go 3 to the 4th plus 3 to the 3rd minus 7 times 3 to the 2nd minus 3 plus 6. That's going to give me basically the remainder. Or I could use synthetic division. 1, 1, negative 7, negative 1, and 6. Make sure you don't have any holes here. If you do, what do you put in place? 0. Okay, bring this straight down. 1 times 3 is 3. That's 4. That's 12. That's 5. That's 15. That's 14. Is that 42? 48. Is this a solution to the problem? No. What does this tell us, though? Perfect. 3, 48 is an actual point on our graph. Is it that helpful? Yeah, not really. It's just one extra point that might exist on your graph. So then I'm going to take 2 and see if 2 works. So I get a 1 times 2 is 3. What do you know? It, 2 is a solution. 2, 0 is a point on the graph. It's a solution to the problem. Yeah?
How do you know if it's a solution or not?
This very last term has to be 0. If it's not 0, it's not a solution.
Good morning, Cherry Creek High School.
All right, so if this is a solution to the problem, what binomial does that go to? If 2 is a solution, what binomial does that belong to? So think about it. X equals 2, so what's the binomial that it sticks with? X equals 2, so what's the binomial? There you go. So if x is equal to 2, then x minus 2 is the binomial it belongs to. So that means that x minus 2 times this, if I plug everything back in, what degree is this right here? If this was fourth, what is this now? Third. Okay? So then you'll have a problem like this on the test where it's going to say, hey, factor it completely. So you're going to have to use this. And I might give you a solution, or I might say, hey, look at your calculator and figure out where the solutions are. Now this one also had, let me go do this. This one also, if you graph it, looks like -1 also works. So once you have found a solution here that works, don't go dividing back into the original. Divide into what was left over here. Okay? So then, see if -1 works. If it should work because it showed up on the calculator. 1 times -1 is -1. That's 2. That's -2. That's -3. That's +3. That's 0. What binomial does this belong to? X plus 1. So now, if I were to take x plus 1 and x minus 2, FOIL them together, and multiply it by this, what is this? What degree is that then? Second. It started with fourth. I broke it down, found a 0. It becomes third. Broke it down, found another 0, which is now second. Now the second could work nicely. I could go to this. Okay? And at this point I could say, well, let's factor it, or use the quadratic formula. One of the two is going to work. Okay? What two numbers multiply to give me -3? So I got 1 and 3. One being positive, one being negative. Which one has to be positive to add to 2? 3 has to be their positive. But let's say you're like, I'm not that good at factoring. Well, if you're looking at your screen, you're going to see what solution does this go to? 1. So you then, if you did synthetic division using the 1 on this, bring it down. 1 times 1 is 1. That's 3. That's -3. That's 0. What degree is this one down here? Fourth, third, second, first. So then I get x plus 3. Oh, wait, that's the same as that. So what is the true complete factored form of this? What is the complete factored form? All the binomials of that. X plus 1. What else? X minus 2. What else? X minus 1, x plus 3. So if I were to take this and FOIL it all back together, I'm going to get x to the 4th plus x to the 3rd minus 7x squared minus x plus 6. And that's how you would go about doing that particular problem. Did I answer everything? Okay, cool. So
how would you find it to use the other method?
help me out.
Calculator.
Okay, so if you plug this into your calculator, usually what's going to happen on your calculator is you're going to be able to see it crossing, a definite crossing on your calculator one spot. So you knew the intersect, but a lot of times, I'll tell you the one on the test, they're going to come out to exact values. I mean, it's going to be obvious. Like you have 2 tick marks. If it's going right between the 2 tick marks, don't use that one. If it's going right through, on the graph, it looks like this. So let's say you had tick mark here and a graph comes right through it. Use -1. But if you had like over here and it came down like through here, don't use that one because you don't know exactly what it'd be. Though you can find it and it'd be like 10 decimals, you don't want to go synthetically divide 10 decimals because this is probably actually an irrational 0 because it's a non-repeating decimal, where this is a rational 0. Okay? All right. Then we need to sketch some graphs. Sketch some graphs, right? Can I borrow your piece of paper? Back to you, I promise. Okay, so 10. We have 4 problems that we're sketching, right? Okay, these particular problems we want to graph on. We want to find the domain, any vertical asymptotes, horizontal asymptotes, any holes, and find the oblique asymptotes, which are sometimes called end behavior asymptote. Okay, problem number 1. First problem. What definitely is going to be a value that we cannot plug in? Yeah, we cannot allow x to equal -2. So x cannot equal -2. Now, is that a hole? I don't know if it is or isn't. I would say look at the numerator. If it doesn't look like it's going to factor easy, I'd say more than likely don't go and try and figure if this is a hole or not. So unless it's truly factored out for you easily, don't go and see if it's going to be a hole. So I'm going to say that there is no hole on this problem. Okay? I don't think x plus 2 is going to be a binomial up top. Okay? So my domain of this problem is going to go from -infinity to -2, and from -2 to infinity. Why do we have rounded brackets at -2? Can't equal it. It can equal everything else except for those values. Okay, is there a vertical asymptote? Yeah, this right here is my vertical asymptote. It's a vertical line. It's a vertical line that my graph can't cross. Okay, horizontal asymptote. Degree on top is bigger than degree on bottom. Horizontal asymptote? No. Horizontal asymptote? Nope. Okay? So remember, you're going to have to know the rules. If top is bigger than bottom, none. Equal, we'll get to that. We'll get to the last one. Okay, I think we have enough information to get a basic sketch of this graph. Okay, I know that at -2 is going to be kind of a no man's land. So I could do a little sketch like that saying I can't cross that. Okay, it's not necessarily part of the graph, but I can't cross that. Okay, what is this graph going to necessarily look like? Well, if I don't have a calculator, I'm not quite sure. I'd probably say that it's going to look something like this. Maybe something like this. I don't know for sure, but I'm just making an assumption. I know it's not going to go right close to it, but I do know that 2, or this -2 right here, is goofing up the graph a little bit. And it could either grow real quickly or not. Or the graph maybe could look like this. Okay, one or the other. How do you know for sure? Well, if you wanted to, just take the -2 and plug it into the numerator alone. So that's going to be -16, -16, positive, or -8, positive 26, -6. So I'd say it's -4. So it's probably the blue graph that it looks like, because that's what this is, a certain approach. I'd say that's where we could go with that. Okay? Did I answer all the questions on that one? Hole? None. Vertical asymptote? Yep. Domain? Yep. Horizontal asymptote? sketch of the graph? Got it. Can I see what my asymptote is? Next one. What? Go ahead. Well, if this was on a non-calculated portion, it's not fair for me to say, hey, what does this look like? So you just got to do the best you can. Just realize it's not vertical lines. Just realize it's going away from or coming to it. Okay. Next problem. Just enough time. 7 minutes. All right. I would say it doesn't look like the top is going to factor nicely. So it's probably not going to factor down real nice. The bottom would factor down to x plus 2 and x plus 5. Do you agree with that? And being the top doesn't look like it's going to factor nicely. I don't think that there's going to be an x plus 2 and x plus 5 that are necessarily part of its factoring thing. Okay, there is 4 terms. I can say, let's factor out x squared, and let's factor out -1. That's not going to leave us anything that's left, so it's not going to work nicely. So what can x not be equal to? And? Do you agree with those? So what is my domain going to be? To -5 and? -2, perfect. -2 to infinity. That's my domain. Okay? In this case, we're going to have 2 vertical asymptotes. What are my vertical asymptotes? X equals -2, x equals -5. These are my vertical asymptotes. So if we draw my xy axis, get a crayon, -2, -5. Okay? Do I have a horizontal asymptote? Degree on top is bigger than degree on bottom. Horizontal asymptote? Nope. Nope is an appropriate answer if you want to do that. Or or nuh-uh. What is this graph going to look like? Well, I don't know. It could be something like, I don't know, like this. I don't know. Some could be like that. I don't know. I mean, I'm not going for sure what it looks like. I'm just saying let's gauge it when we figure it out. Vertical asymptote, domain. No holes.
I didn't know there's no top doesn't have the same as the bottom.
Yeah, it doesn't look like the top is going to factor down nicely. Meaning, I don't think I'm going to be able to get the top to have an x plus 2 or x plus 5 in there. If it did, what I will do for you on the test is I will have the top already completely factored out. And I might have the denominator being like x squared minus 16, which you have to know that is x plus 4, x minus 4. And if one of those matches up. Does that make sense?
Yeah, then there would be a hole.
There would be a hole. So it has to be the same binomial top and bottom. All right.
So the best thing to do is to just factor these out first.
Yeah. But I will tell you that the bigger one on the test, I will have the whole top factored out for you, and the bottom will be like the difference of 2 squares. So you'll have to be able to recognize how to break that down. Some of them will be graphed, yes. So, almost done. Shh.
Wait, so is the test calculator or non-calculator?
Yeah.
Which stays which?
I don't know. I'm sorry. I haven't thought that. It's Monday. I'll bring them both. We'll do a vote. We'll make it work. All right. On this one, is there a horizontal asymptote? If so, what is it? It's 1/2. So y equals 1/2 is my horizontal asymptote. That's about as far as I'm going to go on this problem. How do we know that? Degree on top equals degree on bottom. And then last problem. You could factor the top being x plus 3, x minus 3. You could factor an x out. You have x and x minus 4. No holes. Degree on top is less than degree on bottom. What's the horizontal asymptote? Y equals 0. Okay? Is there end behavior on this one? Is there an end behavior asymptote here? No. Is there an end behavior here? No. Is there an end behavior on this one? Yes. Okay. Is there an end behavior on this one? Yes. Why is there end behavior on the top has a larger exponent than the bottom? That dictates the end behavior. If the top has a higher exponent than the bottom, then you have an end behavior or an oblique asymptote. If the degree is equal or if the degree is less on top than bottom, no end behavior asymptote. This is recorded.